On August 15th, 1977, a strange signal from the constellation Sagittarius was received by the Big Ear radio telescope. The signal, known as the WA signal, reached an intensity up to 30 times higher than the usual signals and had a duration of 72 seconds. Its name comes from the note written at that moment by the person who discovered it, Jerry R. Eman, collaborator and SETI project, a project for the search for extraterrestrial intelligence founded by NASA in 1960. The WA signal is, among all the strange signals received up to now, the one that has the greatest likelihood of having been emitted by intelligent extraterrestrial beings, despite its origin still being uncertain to this day. In a vast universe, 40 billion years old and containing 500 billion galaxies, science is convinced that there must exist, or must have existed, extraterrestrial intelligence. In this vastness, it would seem that there should be fullness of life out there. With this conviction, human beings have searched for it and still search for it incessantly. State-of-the-art radio telescopes track the sky day and night, year after year, in search of any sign of extraterrestrial intelligent life. Nevertheless, in 2009, everything changed. That year, NASA launched the Kepler satellite into space. And thanks to it, we have found thousands of Earth-like planets where conditions for life might be possible. This has meant, undoubtedly, a total revolution in the search for extraterrestrial intelligent life. Given the important advances in astrophysics, some scientists believe that there is a chance of finding extraterrestrial intelligence in the next decades. Seth Shostak, astronomer and director of SETI, Search for Extraterrestrial Intelligence, declared before the House Science Committee of the American Congress that in a couple of decades, we will have found evidence of its existence.
The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing.
A first contact could be close. The question is, do we really want them to find us? What will these forms of life be like? What will their aims be? Is anybody out there? Given the millions of billions of Earth-like planets, life elsewhere in the universe, without a doubt, does exist. In the vastness of the universe, we are not alone. Albert Einstein. 4.5 billion years ago, in the vastness of the universe, the Earth, our home, was formed. From the birth of the universe, it took 14 billion years for human beings to arise, just 6 million years ago. To give us an idea of the time which has passed until our first steps, Carl Sagan made a time comparison in which, if the age of the universe was a year, the Big Bang would have occurred on January 1st. On September 8th, the Sun would have formed. On September 11th, the Earth would have formed, and we would have been born the last day of the year, December 31st, at 11:39. How many things must have happened in other places during the same time?
Today, when we take a look at what we know about the universe, and what we know about the origins of life on this planet, it leads us to think that the same things that happened here might well have happened elsewhere. And so life beyond this planet is quite plausible in terms of the science that we know today.
We see the organic building blocks that are essential to life on Earth. And so the raw stuff that's necessary for life is out there. The places that life could live is out there. The big question is, do they come together and form a second Genesis?
We take up a tiny place in the immensity of the universe. The Milky Way, the galaxy we live in, might have around 100 billion stars, among them our Sun. In total, it measures around 100,000 light years in diameter.
Maybe there are a million, maybe there are a billion, maybe there are 100 billion planets in the Milky Way galaxy that could support life, the kind of planets that earthly life could survive on. How many of them have cooked up their own life?
Here, from one end of the Milky Way, we, an intelligent civilization, wonder if it's possible that we are alone in all of this vastness.
There's just a lot of real estate, a lot of room for life in space. We've now learned that planets are as common as cheap hotels. They're all over the place. There are 1 trillion, that's 1 million planets just in our own galaxy. If there is no life on any of them, then Earth is a miracle. A miracle. And I'll tell you this, for scientists, believing in miracles is usually not a good strategy.
When we think about how vast the universe is, it would be incredible if there's no other life out there. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life is prevalent throughout the universe.
That's why human beings, in their enthusiasm for knowledge and exploration, have started the search for intelligent life, with the hope of, sooner or later, finding it, or being found by it.
Oiknis poteste chairete, Eirenikos pros philos eleluthamen philoi.
Paz e felicidade a todos. تحياتنا للأصدقاء في النجوم يا ليت يجمعنا الزمان.
Բոլոր անոնց, որ գտնվին Եզերքի միքամազություններեն անտին, ողջույններ.
पृथ्वी ઉપર વસનાર એક માનવ તરફથી બ્રહ્માંડના અન્ય અવકાશમાં વસનારાઓને હાર્દિક અભિનંદન. આ સંદેશો મળે વળતો સંદેશો મોકલાવશો.
This search can be done in two ways: tracking signals that may come from any extraterrestrial civilization, or sending our own messages into space, which may be received by one of those civilizations someday.
Active SETI, also sometimes called METI, messaging extraterrestrial intelligence, reverses the roles. Instead of passively listening for a signal from another civilization, we send intentional, powerful signals to nearby stars in the hope of getting a reply back.
With this goal, in 1977, the most elaborate and comprehensive message to date, The Sounds of the Earth, was launched into space. A moving introductory message including everything that human beings considered that an extraterrestrial civilization should know about our species. It was included on a golden record on each of the Voyager interstellar space probes, launched that same year from Cape Canaveral.
It was a golden record. On one side, there were encoded music from around the world, greetings in 55 languages, a 12-minute sound montage of the evolution of life on Earth. And on the other side, there were pictures, over 100 pictures describing some basic mathematical principles and the diversity of life and culture on Earth.
The content of the recording was carefully chosen by NASA and a committee chaired by astronomer and author Carl Sagan. The audio section has a salutation in English from the UN General Secretary and short messages in 55 languages, welcoming and wishing peace to all forms of life.
Witajcie, istoty z zaświatów.
Riadumelisa Marela.
Hello from the children of planet Earth.
But that one was not the only message sent.
There have been a few symbolic transmissions to other worlds. The most famous transmission to another civilization happened in 1974 from the world's most powerful radio telescope in Arecibo, Puerto Rico. It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth.
Nevertheless, the search for extraterrestrial life is not founded just on the sending of messages in the hope of a response someday, but on the development of a search for signals that may indicate the existence of that intelligent life.
SETI, as a scientific exploration, actually got its start within NASA in the life sciences portion of NASA. People were interested in the question of life beyond the Earth, and this program developed within NASA. It launched actually in 1992. It was called the High Resolution Microwave Survey. In 1993, Senator Bryan from Nevada terminated NASA's funding for SETI, and he terminated with a vengeance so that NASA was unable to recover and come back the next year with another SETI program. So at that point, because we had already formed a nonprofit institute called the SETI Institute to help NASA stretch its funds as it did this SETI work, in 1993 we said, okay, we've got a nonprofit, we're just going to go out and raise money to do this privately.
The SETI Institute is nowadays the main world institution devoted to the search for extraterrestrial intelligence.
It's a project called SETI, the Search for Extraterrestrial Intelligence.
This search is based on the use of radio telescopes. Radio telescopes receive radio waves. As we can't go to space aboard spacecrafts to find that intelligent life, what we look for are radio signals.
What we're looking for is a signal that's at one spot on the radio dial. Just like when you're listening to the radio in your car. You know, you tune across the dial, you hear static everywhere, and then at one spot you're near, and there's a station. Okay, that's the signal that's produced by a transmitter somewhere. It's not natural static. It's not like a quasar or a pulsar or galaxies or hot gas, cold gas. All those things in space make radio noise, but it's all over the dial. So we look for signals that are at one spot on the dial, and of course the source of the signal has to be up in the sky. Those are the kinds of criteria we use to know that even if we don't know what it means, we at least know they're there. They're on the air.
One of the biggest SETI projects, started in 2007, is the Allen Telescope Array, which seeks to install 350 antennas to receive possible messages from outer space.
We designed this. We went to Paul Allen and asked him to fund it, and he was generous to fund the first phase of construction of what we now call the Allen Telescope Array. It's in Northern California near Mount Lassen. The Allen Telescope Array has 42 telescopes. Someday we hope to grow it to 350.
The Allen Project will become the most powerful instrument in the search for signals from other civilizations in our galaxy. Since it was launched, after just a few months in operation, it has been able to analyze the same amount of area of the universe as in the last 45 years of SETI's existence. Another of SETI's most famous innovative projects is SETI at Home. It was started in 1999 by astronomers at the University of California in Berkeley, and it uses an army of millions of amateur internet users. From home, anyone can be part of this enthralling pursuit. The screensaver analyzes some of the data that comes from the Arecibo radio telescope in Puerto Rico. Up to now, more than 5 million people from all over the world have participated and are processing all of the info captured by the Arecibo radio telescope. the SETI at Home project has grown so quickly that it is the biggest ever of its kind. Both projects, Allen Telescope Array and SETI at Home, have been a huge advance in the search for intelligent life, giving hope for discoveries in the near future. But undoubtedly, what has radically revolutionized and pushed the search for extraterrestrial intelligent life is the Kepler mission, which is focused on the search for potentially inhabitable planets. It was launched by NASA on March 6, 2009, and orbits the Sun looking for extrasolar Earth-like planets where life may be possible.
Kepler, which is a space-based telescope that was launched about 5 years ago, is on the hunt for planets. Kepler has found literally thousands of planets or planetary candidates. It's a planet-finding machine.
The Kepler spacecraft has been a game changer in the search for other intelligence. Kepler now can tell us which stars have planets around them and which of those stars are Earth-like. That means we now know where we can point our telescopes to look for a twin of Earth.
In 2011, for the first time ever, Kepler provided scientists with a census of the Milky Way. For the first time ever, we can calculate how many stars in the Milky Way could have a planet like ours. Around 1 billion.
So one of the big triumphs of astronomy in the last 2 decades is to show the majority of stars have planets. There are planets all over the place. There are more planets than stars.
According to the data, in the near future, millions of inhabitable planets may be found just in our galaxy.
What Kepler has shown is that maybe 1 in 5 stars has a planet which could have liquid oceans, a bit of an atmosphere. In other words, the kind of place where you might want to build yourself a house, right? So 1 in 5 means that just in our galaxy, there are tens of thousands of millions of cousins of the Earth. That's a lot of real estate.
This data is crucial to answering the question of whether we are alone in the universe and helping us to resolve some unknowns of one of the most famous equations in astrophysics, the Drake equation, which is now of major interest.
The Drake equation is a way to grapple with all of the issues most central to determining how many civilizations are there out there in our galaxy trying to make contact. The Drake equation looks at 7 independent factors and tries to put a number on each of them.
So you multiply all those up, and you come up with a number that we call N, the number of potentially communicative civilizations in the Milky Way. Our star is the rate at which stars have been born in the Milky Way galaxy over the last few billion years. So it's a number that is stars per year. Our galaxy is 10 billion years old, and early in its history, stars formed at a different rate. All of the F factors are fractions. Each one must be less than or equal to 1. F sub p is the fraction of stars that have planets. N sub e is the average number of habitable planets in any planetary system. F sub L is the fraction of planets on which life actually begins, and F sub I is the fraction of all those life forms that develop intelligence. F sub C is the fraction of intelligent life that develops a civilization that decides to use some sort of transmitting technology. And finally, L, the longevity factor. On average, how many years do those transmitters continue to operate?
That is perhaps the most elusive term of the Drake equation. As we look into our own future, we wonder, will we survive as a technologically adolescent civilization? Will we last long enough to make contact? That is the big unknown.
The Drake equation includes a series of terms whose value we can't know exactly.
It's just a fantastic framework with which we can organize our ignorance, because you can't solve the equation. There are no right answers to that equation, not yet.
As we shift into the more biological and cultural terms of the Drake equation, we move into areas where we're uncertain.
But during the last few years, we've seen how exoplanets have arisen in front of our eyes, thanks mainly to the Kepler space satellite.
When Frank Drake first wrote down the Drake equation back in 1961, he put his own personal estimates into each of those vectors and came up with a number, his estimate, which was 10,000. So within the Milky Way galaxy of 100 billion stars, he thought 10,000 of those stars might host technological civilizations.
What do we know now that we didn't know in 1961? Well, we know one or two of those terms a little bit better. And they kind of agree with the optimistic estimates that were made 50, 60 years ago.
There are other estimates that are extremely pessimistic. There's only one, and it's us. Carl Sagan had a number that was more optimistic. He said probably 1 million was his guess. We think we know that our star and N-sub-E are both numbers that are closer to 10 than, say, to 1. And all the F factors are less than 1. Some of them may be much less than 1. But of all these unknowns, the biggest unknown is L. So perhaps the most useful version of the Drake equation is simply to say that N is approximately equal to L. The information in this equation is very clear. Unless L is large, N will be small.
And these are estimates just for our galaxy. But we don't have estimates just for our galaxy, but for the visible universe. This fact multiplies the chances for the existence of extraterrestrial intelligence. The Hubble Space Telescope has given us an approximate calculation of the total number of galaxies in the viable universe. 100 billion. So we can calculate the number of Earth-like planets in the visible universe. 1 trillion Earth-like planets. The universe is 14 billion years old, so there has been time enough for intelligent empires to arise and possibly fall. It would be miraculous if no other advanced civilization anywhere had ever existed. It's just a matter of time until we find them. Radio telescope technology is becoming more and more advanced, and some scientists believe that the first evidence will be found in the next decades.
So far, we've looked at a little over 10,000 stars very carefully with the Allen Telescope Array. In the next couple of decades, that'll be 1 million stars. And by the time you've looked at 1 million stars, that's a reasonable number to find intelligent life, if it's really out there.
In fact, people like Craig Venter and Daniel Cohen have said 20th century was the century of physics. 21st century is going to be the century of biology. But my colleagues and astrobiologists and young scientists are saying, yes, the century of biology on Earth and beyond. This coming century, this 21st century, could well provide us with evidence of life beyond Earth and a biochemistry that's different from the only one we know.
The chance of an imminent discovery brings with it a controversial question. What will the first contact be like? What could human beings say to another intelligent species? What introductory message can we compose about human beings, that species that inhabits one of the edges of the universe, and who have developed enough to wonder if there is anyone else out there, or to try to find them?
There should be a deliberative process to think about how we want to present ourselves to other worlds.
And that is a dynamic conversation that we're having now in the science community. Should we transmit? If we do, who should speak for Earth? What should they say? In what language? How?
It's not a simple task to ponder our first introduction to an extraterrestrial intelligence, and the even more complicated question of how to compose that message to make it understood.
How we would say something meaningful to another civilization. It is going to be one of the most tremendous intellectual challenges humankind has ever faced.
composing a message that can be understood by aliens will be extremely difficult, and conversation may be impossible.
In order to make contact with another civilization and truly understand them, we have to find a language that any scientist who is engaged in SETI anywhere in the galaxy will understand.
This is what's called active SETI, or METI, messaging to extraterrestrial intelligence.
If you can build a radio transmitter anywhere in the galaxy, you have to know that 2 + 2 = 4. And so it's basic mathematical principles like that that we use as the foundation for a language to communicate with extraterrestrials.
In terms of the message content, how it should be sent and what it should say, what would we say about ourselves? And what are efficient encoding schemes, and how do we provide a tutorial so that they can figure out what the scheme is?
My suggestion is to send the internet, right? Send so much information that they can look through it and find pictures, videos, sounds, text, of course, and they'll be able to understand it. It's sort of like the hieroglyphics.
Several messages have already been sent to space, and we hope to receive an answer someday. The first sent message was attached to the Pioneer 10 space probe, launched by NASA from Cape Canaveral on March 2, 1972. A golden anodized aluminum plate designed by astronomers Carl Sagan and Francis Drake was affixed to the probe. It was a kind of an interstellar message in a bottle. On it, drawings of 2 human figures appear, one feminine and one masculine, with the image of the spacecraft behind them to show the proportion of the human silhouettes. Our address in the universe was also included, as well as a scheme of our solar system. Another similar plate was affixed to the Pioneer 11. The next message, sent in 1974, was designed by the Dr. Frank Drake and transmitted by the Arecibo radio telescope in Puerto Rico. This message is generally known as the Arecibo message.
It was a very simple message. It took 3 minutes to send, and it provides a mathematical and scientific overview of life on Earth. It starts with a description of our numbering system in a binary code, numbers from 1 to 10, and then using those numbers, a description of chemical elements that are essential to life on Earth. And once we can talk about those chemicals, we can talk about the way they combine into molecules, including DNA, the core of our genetic material here on Earth. The Arecibo message also gave a description of our solar system, the population of our Earth, even a diagram of the telescope that was used to transmit the message.
1977 saw the launch of the Sounds of the Earth, the most elaborate and comprehensive message to date. Recorded on golden records, they were affixed to each other on the Voyager spacecrafts. Besides salutations in 55 languages, they included an audio section devoted to the sounds of the Earth. Volcanoes, lightning, wind, laughter, and the message in Latin, per aspera ad astra, through hardship to the stars, in Morse code. Also included were eclectic selections of music from different cultures. The Brandenburg Concerto No. 2 by Bach, the Magic Flute by Mozart, the Melancholy Blues by Louis Armstrong, Beethoven's Fifth Symphony, as well as traditional music from different cultures. In addition to the audio, 116 photographs were sent showing different forms of life on the Earth and human society, mathematics definitions, the structure of DNA, a diagram of the fertilization and birth, a violin with musical notes, and so on. Will anyone receive these messages? Will we have an answer? But above all, what will those who receive this message be like?
I think that one of the best things about finding life, a second Genesis, life that isn't related to us, somewhere else will be to begin to understand how biology can be different.
I mean, we don't even know if they'd have the similar biochemistry. But on the other hand, we're carbon-based life forms, and carbon, which is all over the universe, of course, is great at hooking up with other atoms to make complex chemistry, and since that's what we are, they might be carbon-based. That's not crazy.
We're having a hard time figuring out what other ways there might be. We're working on it from the bottom up with synthetic biology, trying to build life in other ways. But I think life elsewhere will have evolved to be perfectly suited to its environment. If the environments are similar to ours, then there could, in fact, be a lot of similarities. If the environments are extremely different from those that we enjoy here on this planet, then I think it's unimaginable. I'd love to find out what we can't imagine.
In fact, as we imagine the kind of beings we make contact with, they may not be biological beings at all. On Earth, we are anticipating computers becoming advanced enough that they may even deserve the term intelligence in the next century or so. So if we make contact with a civilization that's thousands or millions of years more advanced than we are, the intelligence on the other end of the line may be an artificial intelligence.
These hypothetical forms of life may have abandoned their biological bodies a long time ago to create a computer body. They may have the ability to build a quantum computer with an extraordinary computing power, a super intelligent device with the same capacity as a conventional computer that occupies a whole planet. Then they may have lost their consciousness of the self to be absorbed by a global digital network of minds, a great collective consciousness.
But in terms of what they'd be like, what they'd look like, nobody can really say, except this. Probably within 100 years, we're going to develop thinking machines here on Earth. So I think it's very likely that if you actually pick up a signal coming from elsewhere, it's not coming from some sort of biological being, it's coming from a machine.
The search for extraterrestrial intelligence is not really different from the search for our own future. The absolute ignorance about the possible aims of an extraterrestrial intelligence is what has led some scientists to voice their misgivings about announcing our existence to extraterrestrials, at least until we know their intentions toward us.
Active SETI is a controversial topic. No less than the cosmologist Stephen Hawking warned, do not transmit to ET. When he said that in 2010, his concern was that aliens may invade Earth to strip mine our planet, taking our rare resources. Well, Hawking is a genius, but he can't predict the future. And so there's no way he could have told that Earth-like planets are distributed everywhere. But even if there is a danger, even if another civilization can come to Earth, it's too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There is no added danger of transmitting signals through active SETI.
In any case, considering the data we now know, a first contact may be possible in a short time. It's also possible that some civilization has already listened to our messages. Nevertheless, how is it possible that if there are other civilizations, we haven't yet received any evidence of their existence? This is what is known as the Fermi paradox.
The physicist Enrico Fermi famously asked, where are they? The idea was, if in fact the universe is populated with life, why haven't they come here?
The formulation of that paradox arose when the physicist Enrico Fermi was working on the Manhattan Project, whose aim was the development of the US atomic bomb. Fermi's answer to his paradox was that every advanced civilization develops, along with its technology, the potential to exterminate itself. as was thought to be happening at that time. The fact that other extraterrestrial civilizations had not been found implied for him a tragic end for humanity. However, there are several possible solutions to the Fermi paradox. They do exist, but they are not communicating with us. They do exist and communicate, but we can't hear them. They do exist and have been here, but we weren't. They do exist, but most people don't know it yet. They have disappeared. Maybe these civilizations have already destroyed themselves as a consequence of a nuclear war or some other cause. But we find even more solutions to the paradox.
Well, there are a lot of answers to the Fermi paradox. One is that it's actually very difficult to travel between the stars. Even over the course of long periods of time, it takes a lot of energy, it takes a lot of commitment, and anything that you can gain in terms of information, you could get a lot cheaper simply by sending radio signals.
Another possible solution is that we aren't interesting to them. If some civilization were able to come to the Earth from the stars, it would have to be thousands or millions times more advanced than ours, and we may not have anything interesting to offer them. Such a civilization might consider us as primitive, as we consider a simple beehive. Would it make any sense for us to interact with bees and try to make them understand our advances in spacecraft missions, nuclear energy, or quantum mechanics?
Or maybe there is colonization and we just don't happen to see it because it's not nearby or it isn't very obvious.
Paradoxically, the galaxy could be filled with intelligent forms of life, but we are so primitive that we have not even realized it. Another explanation for the Fermi paradox is that we may have already received those signals, but we haven't realized it. We haven't perceived the signals, or we haven't been able to understand or decode them. In this case, some strange signals from outer space have been received. Their origins are now being investigated, and they have posed serious questions for scientists.
The most famous signal that's been detected came in 1977. It was at Ohio State University's Big Ear radio telescope. And in the course of listening for signals from another civilization, there was this message that was strong, that was spread out over frequency. It looked exactly like the kind of signal we would want to get from ET.
During his work on the night shift on July 15, 1977, Jerry R. Eman, professor of the State University of Ohio and SETI project volunteer, observed the weird transcription of the radio signal made by a computer in a section of paper feed to confirm later that it was the most intense anomalous signal detected up to that point by a radio telescope. The signal, of unknown origin, had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals, and had come from the constellation of Sagittarius.
In fact, it was so astounding that when the technician was looking at the printout the next morning, he wrote "wow" in the margin, and that's become known as the wow signal.
The computer processed the signals received into a series of alphanumeric characters. It wrote the sequence 6EQUJ5, which has kept the international scientific community on edge until today. Eman and his team studied the signal in detail. In the end, they were able to rule out that it had been part of any interference coming from the Earth. So during the following month, the operators of the radio telescope tried to reposition the signal, but they didn't succeed.
Well, many times in the decades since then, astronomers have looked at the same part of the sky to see whether they can find the wow signal again, but we've never been able to replicate it. So the key to progress in SETI is to be able to find a signal that looks as good as the wow signal, but now to be able to find it not just once, but over and over and over again.
Today, the origin of that signal is still under investigation. Another signal which provoked important debates was the radio source SHGB-02+14A, discovered in March 2003 by SETI at home and announced in New Scientist on September 1, 2004. Since SETI at home started, more than 5 billion signals have been detected that, because of their mathematical profile or their lack of repetition in time, have been ruled out. Among all of them, the candidate SHGB-02+14A was one of the very few that was confirmed again, and the only one to maintain a high statistical chance of being intelligent and of extraterrestrial origin. Another relevant signal was the one observed by the Australian astronomer Regbur Bathal, a SETI collaborator, who found a strange signal close to what years later would be confirmed by NASA as the first habitable planet, the Glycel 581, just 20 light-years away. On the NASA website, in the section Astrology Picture of the Day, we found an explanation for the signal. No one knows for sure what caused this signal. There is a slight possibility that it just might originate from an extraterrestrial intelligence. Many unusual signals from space remain unidentified. The study of signals possibly emitted by an extraterrestrial intelligence is a delicate matter that requires a great deal of confirmation.
First, if you think you have a signal from an extraterrestrial, make sure, check with colleagues, double check your data. And then secondly, if you're really pretty sure you found it, tell the whole world.
Despite countless conjectures about a possible contact or some evidence that is being hidden, SETI states that we haven't yet received a confirmed signal and makes it clear that as far as SETI is concerned, it wouldn't be a piece of information to hide.
A lot of people in this country figure the federal government would cover it all up because the public couldn't handle the news. Well, we know that isn't true because we've had false alarms. And what actually happens is the media are very interested. The newspapers, the radio shows, TV shows, they call you up right away if you get any kind of interesting signal.
So according to the SETI protocol, the day they confirm the first signal indicative of extraterrestrial intelligence, they will make the news known worldwide. A fact that, considering technological advances, may occur in a short time. Seth Shostak declared before the House Science Committee of the American Congress that in a couple of decades, we will have found evidence of its existence.
The chances of finding it, I think, are good, and if that happens, it'll happen in the next 20 years, depending on the financing.
There are sort of guesses as to how many societies might be out there broadcasting, and those guesses run from maybe 10,000 to 1 million. Well, if the correct number is anywhere in that range, then we should find something within a few decades. So, you know, this is not like building cathedrals in the Middle Ages. This is something that's going to work within one generation, if it's going to work at all.
If I had to bet when we will find intelligence beyond Earth, I'd say in the next 20 years. And it's simply because technology is advancing all the time. SETI success depends on computing power.
What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Is humankind prepared?
So what happens if we find a signal? If we find evidence that they're out there, you know, people will still go to work the next day, or if they're in school, they'll still go to school. They won't divorce their spouses. There won't be civil unrest. They won't be rioting in the streets. It's just that we will know something really important, that as wonderful as Earth is, as wonderful as our species is, we're not the only kids on the block. And I think it's good to know that if it's true.
In January 2010, the Royal Society held a conference entitled The Detection of Extraterrestrial Life and the Consequences for Science and Society. The introduction of the conference was as follows. Astronomers are able now to detect planets where life may exist. And the living generation could see the signature of extraterrestrial life being detected. Should it turn out that we are not alone in the universe, it will fundamentally affect how humanity understands itself, and we need to be prepared for the consequences.
Over the long term, if you actually did get a message and could understand it, of course, that could be very transformative. Imagine, giving, I don't know, Neanderthals the keys to your local library. Say, hey, you might want to read some of this stuff. I mean, that would change everything for them. So there is that potential, although I think it's a fairly far-fetched idea.
Concerned that a discovery could be close, humankind has slowly started to prepare itself to establish a protocol procedure. Neither a country nor a collective of people would be represented, but all of humankind.
There's a protocol called the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence. And this provides guidelines about what do we do next. The most fundamental issue raised in this protocol is before there is a reply, there should be broad-based global discussion. That if we are to speak to another civilization, if we are to send a response, it should be a response that has gathered global input. This wasn't transmitted to the SETI Institute or to any other organization. The message was transmitted to Earth. It belongs to the whole Earth. It should be shared widely.
Most scientists agree that a finding like this would alter and transform the status quo in many ways. What would be its effect on our society, our science, our technology, or our religion?
So for me, detecting another civilization is a way of coming to a better understanding of who we are as human beings. It would mean a chance to see whether the ways of knowing that we've developed here on Earth, our math, our science, our ways of expressing ourselves, our music, our art, are they somehow tapping into something that goes beyond Earth, or are they uniquely ours?
The discovery would be on the same level as those of Copernicus and Darwin, and as of the transforming events in human history. However, it will be decades before people get used to the idea that we are not alone in the universe, and its real meaning becomes deeply ingrained, as occurred with the heliocentric cosmology and biological evolution. It's likely that our first contact with an extraterrestrial civilization will happen when the Allen Telescope Array detects a message that confirms, at last, the existence of extraterrestrial intelligent life, or when one of the people connected to the SETI at Home project announces that his computer has decoded some of the signals of the Arecibo telescope. Then, our first contact will be a unidirectional conversation. We might capture some intelligent message by chance, but it could take decades or centuries before our answer gets to them, given the huge distances of the universe.
Let me tell you what my hope for the impact of the detection of a distant technology would be. What I hope is that we can make it understood to the people on this planet that the only way that contact happened was because, on average, technological civilizations have a long lifetime. We're sitting here as a very young technology, and we literally do not know whether it's possible to grow old, to be able to be wise enough to manage our population, to shepherd our planet, to go forward into a long future, long in cosmic times. But if we find someone else, we know the answer to that question. We get a proof of existence. It's possible to grow old. Somebody else figured out how to do it. And I would hope that that would motivate us to find solutions to the problems that we face today. We know that somebody else made it through this bottleneck, this technological adolescence. I'd hope it would motivate us to find answers for ourselves.
Today we know that the first contact may occur in not too a long time. It's not easy to figure out what will happen in this first communication, if it will be something positive or harmful to human beings. What is clear is that it will be a turning point in the life of the human species.